right, so we have an air conditioning system operating on a reversed Carnot cycle. It's required to transfer heat from a house at a rate of 750 kilojoules per minute to maintain its temperature at 24 degrees Celsius. If the outdoor temperature is 35 degrees Celsius, we want to find the power required to operate that air conditioning system. So I've got everything set up here. I've labeled my high and low temperature reservoirs. I recognize that the high temperature reservoir is the hot outdoors. The low temperature reservoir is, of course, the indoors, which I'm keeping cool. And the rate at which I'm removing energy, thermal energy, from the cooled house is 750 kilojoules per minute. And it says that it's a Carnot cycle, or a reversed Carnot cycle, which means that it's a completely reversible refrigeration cycle. So with that in mind, I do need to go ahead and set up, figure out or define my coefficient of performance for a reversible refrigeration cycle. And I recognize that if I get the coefficient of performance equation for a refrigeration cycle in terms of Q's, and I switch out the Q's for T's, I get TL over TH minus TL. So if you need a review or a refresher on why that is, review the video on second law limits for efficiency of cycles. There's a two-part video, 1 and 2, so just make sure that you watch that. And of course, we need to plug things in terms of absolute temperature units. And since I'm in SI units, I go ahead and put it in Kelvin. Plug and chug, and I get a coefficient of performance of 27. Now, it's asking me to find not the coefficient of performance, but the power input required for this cycle. So I also recognize that this is still equal, the coefficient of performance. It's defined as what you're interested in, the rate at which you're removing heat from that refrigerated space, over what you got to put into it, which is the power input, albeit for a reversible cycle in this case. And so I just solve for the W.N, which is the W.N for a reversible cycle, since this is a reversed Carnot cycle. And looks like I've got everything that I need. I've got the coefficient of performance. I just solved for that. I've got Q.L. Q.L was in terms of kilojoules per minute, so I calculate kilojoules per minute. But if I wanted to get it in terms of kilowatts, I could do that. So just a little unit conversion there. So, all right. Well, I hope that was helpful. Thank you for watching, and let me know if you have any questions.